Hello everyone, merge sort, the Java implementation. You can open up your Eclipse program, then we will create a new Java project and we will name it merge sort. Now we will open up here and create a new package, the merge package, and we will create a class, the merge sort class, and we will also add the main method. That's better. Now we can spare some time and copy some things from the cell sort algorithm that we wrote a couple of lessons ago. And we'll go here and we will paste this code, and here we will just make an adjunction merge sort. This will be our new array, and it will have the my array, and then we will set the index that we will start and the end index. Now let's see what's wrong here. So something is missing, and I think this is what something was extra. There we have it, and let's make it a little bit like that. Now we will create this method. So we'll go here, and then we can either create like that with a right click, or you can just go there and say public static void merge sort, and then it will take an integer array. We will name it input, then the start element and the end element. The whole idea here is that we will create two methods. One method will call itself repeatedly, and the other one will do the merging. And what we just did here is the partitioning, the logical partitioning, because we will just define the start here, the start index, and the end index here. So we won't create any new arrays. And now inside that code we will start and write if, and then end minus start less than 2. Then we will open up our brackets and we will return. And what we just wrote here, this will break the recursion. So if this condition is completed, the recursion will be broke. Then we will create the mid start plus end, and we will divide that by 2, and then we will create our recursive methods, the merge sort, that we will take the input, the start and the mid. Then we will create the merge sort that will take the input, the mid and the end. And lastly, we will create the other method, the merge method, and this will take the input, the start index, the mid index and the end index. So this is pretty much our code here, and this is the first method that we write. Now here are some things to point out. Here the end, it will be always one greater than the partition you want to sort, and this is how we can partition the array, this part here. Then the merge sort, the first one, this part here, it starts with an array, start and mid point. This is the end of the partition, the end of the first partition, and it merges the left partition. So this will be a recursive method that sorts the left partition. The other one here, this is the right one, the right partition. It will sort and merge the right partition. The merge method, the final method here, it is how we sort both of the arrays. And like you can see, all of them are recursive methods. That means that they will call themselves repeatedly until they have a result or until the code crashes. So now we're ready to write down our merge method, this one. So we go here and we say public static void merge, and then we will write the merge. We'll start with an array, let's say input, then the start index, then the mid index, then the end index. And we will open up this with 2 brackets. And as you can see, we don't get any more an error here, because we do have the merge sort, this is this one. We do have the merge, this is this one, and the merge sort here is the method that we will call here and that will repeatedly call itself. So let's start writing this method. We will start with an if statement, and we will say if input, and we will write the mid element -1 if it's less or equal with the input element that's on the middle position. Then we need the brackets. Then we will return, and what that means is that if this statement is true, then we are done. And then we need some variables. Let's say I start, we will name it start, it's an integer. Then we will take the j, and it will be the mid. And now we need a temporary integer, let's say temp index, and we'll give it a value of 0. Then we need the temp array, where we will copy the elements inside of it, and we will say it will be of the size of end minus start. So some important things here. We merge the sorted array, and the mid is the first element of the right side and the last element of the left side. So then the mid -1 is one element before and the mid in the left array. So if the mid is greater than that, then we are done. So in other words, if we want to say it much simpler, if the element of the left array are smaller than the right array, then the sorted array is just these 2 arrays together. And that's everything here. And now we see here an error, and that's why I forgot here the bracket, the closing bracket. Exactly. Now let's go further, and this is the tricky part of this algorithm. We will say while I is less than the mid and j is less than the end, then we will open up the brackets like that, and we will say temp index +1, so increment the value of the temp index by 1, and then the input I is less or equal from the input j, and here we will use this statement input I ++. If it's false, then input j++. And then we are ready here, and I didn't close the bracket, I think, or did I? I did it. And let's make it a little more nice, like that. It's a little bit better, I think. And of course, we can erase that one here. Good. So this was the while loop, and in this loop we say we will drop out here. We will drop out when we reach the end of either left or the right array, and we will copy the order numbers to this array. If we have any remains at the left, we will copy them to the right side, and we will create also the next method or the next line to do that. We will take an already created method from Java, so that it will do the work for us. And if some of you wondered about the syntax that we used here, so this is the condition here, and we say, is this condition true? If it's true, then do that. Is this condition false? Then do that. And that's the syntax to do such a thing here. You can spare some lines of code by doing that way. Now let's use the array from Java that will save us a lot more lines of code, and this is the system array copy. We will go here and we will say system array copy, and we will take the input here, input, and then we will say the input start plus the temp index and the mid minus I and the semicolon, temp index. So what we say here, it is we go here. This is also a system array copy. We are just being dropped out of the while loop, and when we are dropped out of the while loop, we dropped out here. This is the first line, and now I need to escape like that. We will be dropped here, so it handles the leftovers from the left array. This is what it does, and we start with the source array. This is the source array here. This is from where should I start copying. This is the destination array, and this is the destination index. Don't forget that the destination index, temp index, counted how many elements we have added. So +1 is at the end of the new overwritten and sorted array, the place that the leftovers should be added. This is the right place. And the last one is the length that we will write, the number of the elements to be copied. And then we need another line of code and another method, again the system array copy, and we have again the source. It will be the temp, then we need 0, then we need a destination copy, the input, then the dest post and the length, temp index. And now we are ready, and we can also test if we have written a functional method. So we can save it and let it run. So as you can see, the first line is the unsorted code, and after we used here the merge sort, and recursively it has called itself many times, we get the right sorted version. I know it might be a little tricky, but I want you to study the code really hard and try to understand the details, the small details of the code. Try to do also some variations. There are variations of this code, and if you don't understand what happens with the recursion, try to see our previous lessons where I do explain what exactly recursion is, and try to understand why do we need here to use recursion and how it helps us. And everything else here is just Java code.